I'm very honored to have Andrew Malope with me from Edward Putudi High School. So, Andrew, what have we got here?
Yes, here we have household gadgets and the kitchen items to be used in a science lesson, because normally we think science can only be done in the laboratory
With fancy equipment.
With fancy equipment and with sophisticated chemicals, and also to show that the schools that are not well equipped can still do the scientific process.
What was the task you set your learners?
I just gave them an overview, a general idea on how to construct a stand that could hold a bottle top.
Okay,
yes.
And this is what we've come up with.
That's it.
Right, show us one or two of these items. Okay, there it is. And what we've got is a
stand that supports the whole thing. And
nice, all made out of wire and bent in and bound up nicely with fine copper wire.
Yeah.
All right, and there it is. And this, of course, has got to hold
the bottle top.
Bottle top.
That's right.
Okay, and there we have it.
All the candle now.
And that and you just put the candle onto there.
Onto there.
That's one.
And then the other one would come with already a gadget that is at home, and what you do is just to add this wire as the.
And again, what's rather nice is that they've been quite careful about the distance between the wick and this, and of course you can adjust that if you really have to.
If you have to.
Okay.
Yes.
And then you're going to put whatever you need to burn into the bottle top right here.
Top. Yes.
Very neat. Where does the science lesson go to from here?
Yes, the science lesson from here was actually to, in a practical, investigative way, to define a few terms that are related to chemical reactions.
Okay.
And also to demonstrate and to show them practically what we mean by chemical reaction.
Okay.
Yes.
So let's do the lesson now.
Okay. Now in the lesson, what is important is also the scientific process.
Okay.
To know a way of solving scientific problems, a scientific problem-solving process, which we call the scientific process.
Okay.
Basically, you have to know what your problem is, and then go through the steps of.
We used to go through the aim, apparatus, method, conclusion, results, conclusion, that kind of.
That kind of a thing.
A step-by-step approach to do.
Yes, a step-by-step approach to do. Then basically, where each learner, after having made his own gadget equipment, then we go on to say, okay, let us see what happens to sugar when it is heated.
Okay.
Each learner does the activity,
right?
And then it also keeps the discipline, and also probe on their inquisitiveness, so that they would like to know more, and the hands-on approach is actually what these youngsters love to do most.
Do you start off with getting them to make predictions, hypothesize what is going to happen here?
Yes. That is what is important. That is what appeal to them to want to go on with the lesson or with the procedure, because they want to see if their prediction is correct.
What kind of predictions did they come up with?
They came up with the right prediction to say the sugar will melt, and then others, of course, came up with the prediction that it will produce a gas. Yes.
Always, if you heat something, you produce a gas.
Yes. Some said it will produce a gas.
Okay.
And then
they realized that it would melt. I think they've probably seen that happen.
Yes.
Okay.
Yes. Yeah.
Did you push them further into suggesting what the browning of the sugar, what that process was, and what was going on there chemically?
At the end, when we started now to interpret
yes,
what we have seen happening, then it is then where
Okay.
I probed the
Okay.
questions to say, what do you think the brown or the
Okay,
black stuff is?
so
Yeah.
for most of them had to do the
Yes, yeah.
activity
The
to
activity.
see what happened.
What happens? Yes.
And then you went back and tried to match explanation to observation.
Yes, that's correct.
Okay, that's
Okay. And
so. So
that is
now we're going to take a look at this. We've lit the candle
yes.
underneath it there, and there we go.
Yeah.
And we see as we get in closer.
Yeah.
I'll just centralize that. Very good.
Yes.
Very good. Now, so we see the sugar starting to melt.
Yes.
It starts darkening.
Yes.
Now, this is interesting. What is burning there?
Yes. Now, the sugar, which was white, turned into a black stuff.
Yeah.
And then it is a change which, when we remove the flame, it stays.
Yeah.
It doesn't go back to the original nature of it.
Right.
And then
permanent chemical
yeah,
change.
permanent
Yes.
chemical change. Now, it was an observation, and then they saw the whole process.
Okay.
And that is what the whole process is, what we call a chemical reaction.
Reaction.
Yes, and in a chemical reaction, one substance changes into something else, which is completely different. What I did is that for them to record all the observations, and then I gave them a task
Okay.
of the interpretation to
Right.
say, go back and research and find out.
What do you think that might be?
Yeah, that might be. Whereas the initial chemical reaction, I represented it by words to say, okay, it is sugar. Then what
Okay.
did you do to the sugar? We added heat.
Added heat.
And then I put an arrow
Right.
to say, what did you observe? A black stuff. I had to guide them to say, now, before this dry black stuff was formed, what else did you see? And there was a liquid
Yes.
resulting from the melting.
Yes.
And then
yes.
I asked them, what do you think that liquid could be? And so that was where I wanted them now to go and find out actually what this new stuff is. And then what do they think would be the liquid released? And then from there, another task was to say, go and represent the whole thing in the form of symbols, chemical symbols.
Okay.
Go and find out what the symbol for sugar is and the symbol for the new stuff.
Right.
After having written black stuff and so on.
Okay,
Yes, so they had
okay.
to come up with the...
It occurs to me that an activity like this can go a long way. In other words, the enthusiasm that you get for a little activity like this, and relatively small investigation,
Yes.
can actually keep interest going in this topic for quite a long time.
Yes.
Yeah, do you find that?
Yes,
is
I found that because one interesting thing is that after this activity, now it probed their minds to go beyond that, to extend the lesson, and also even to cover up some other lessons that were still coming, because they would ask a question like, will salt behave the same way?
Yes.
And then what would say, yes, and then
try
what would
it.
say, try it, let's see.
Sure.
Then they
sure.
would try it and find out for themselves.
Okay, and,
And
so
then
now
so-
they're finding about different kinds of crystals
Yes.
and that kind of thing.
And then from there, maybe the difference in behavior between sugar and salt will probe further questions to say, why are they behaving differently?
Right.
And then that is where it opens an opportunity to research.
Andrew, I congratulate and commend you. I think this is absolutely wonderful. It really is.
It's my pleasure.